we present StyleAligned, a method that enables a text-to-image diffusion model to generate images in consistent styles and perform reference image style guidance. This approach doesn't require any fine-tuning, is simple to implement, and works with a contemporary diffusion model. We start with a brief overview of the task. Once a set of prompts is provided for the text-to-image diffusion, even with the style specified in the prompts, the resulting images have different light conditionings, palettes, and scales and don't share the visual appearance, which is crucial for various applications. We propose a method that modifies the model inference process so that resulting images share the appearance without compromising visual quality and text alignment. The core idea is to share values in self-attention layers between the first style reference image in the batch and the others. Notably, this doesn't require any model fine-tuning or optimization on the inference. The alternatives to the approach we propose have several pitfalls. They either require weights optimization for each new style with the generation time process taking minutes. Some of them can't fully prevent content leakage. When together with the reference image style the model copies some of its semantics. Or require an extensive training on extra curated data, making it inapplicable to work on top of a pre-trained text-to-image model. Our solution has multiple advantages. It works with any diffusion model that has self-attention layers. No fine-tuning is required neither for consistent style generation or for style transfer. The inference overhead is relatively low and consists of doubling the self-attention computation. The method is easy to implement and we provide the code for the diffuser's library. Let us dig deeper into the method details. Diffusion image generation process is formed by consequent image denoising steps. On each step, the image-to-image model performs the denoising step moving from a noised image to a slightly clearer one. Commonly the model is text-conditioned. The recent denoising model architecture is commonly composed of multiple convolutional and attention layers, including the self-attention layers that perform attention mechanisms over the spatial image features. Let's take a closer look at the self-attention. The self-attention layer receives a set of input features, each associated with a spatial location in the generated image. With the projection matrix, these input features are mapped to the queries, keys, and values and then passed to the scaled dot product attention. Commonly the batch elements are processed independently. For each batch sample features, we compute its own queries, keys, and values, and apply attention over them. Our idea is to enable information sharing and allow all of the batch elements to take a look at the first batch element that serves as a reference. For that reason, during the self-attention computation over elements different from the first one, we concatenate its queries, keys, and values, with the queries, keys, and values of the first element in the batch. Before passing to the dot product attention, we normalize the queries and keys with adaptive normalization layer to ensure that the new batch element statistics match the reference batch element statistics. Then the query vectors perform attention to both elements from their own batch index, and from the first batch. This shared attention is applied at every denoising step during image generation. The first element in the batch performs the self-attention only to its own features. Each of the next batch elements performs self-attention to its own features as well as to the features of the first element in the batch. The proposed self-attention sharing happens to transfer only the appearance attributes from the first element while keeping the semantics defined by the text conditioning. Let's move to the method application results. Generating images in the same style is important ability in different creative tasks. For example, given a desired content description like fox, castle, and so on, with a style description like minimal flat design illustration, or black and white rococo art, we can generate a set of style-aligned icons. Or we can create a design for style-aligned characters. Furthermore, we show how our method can generate style-aligned image to a reference input style image. We invert the images into a denoising trajectory by applying a diffusion forward process. Then we can apply our method for generating new images that are style-aligned with the reference inversion trajectory. Here are cool results aligned with some distinguished illustration styles. Here, we can specify two different 3D render styles using our input house renders on the left. We have compared our method to two exciting approaches for style control over diffusion models. We compare to personalization methods that fine-tune the diffusion model over the reference style, and to adapter-based methods that train a specialized adapter that injects features from the reference image during the denoising process. As can be seen, our method generates high-quality results with respect to the reference style without the need for extra fine-tuning or training, which is also confirmed by extensive quantitative experiments. Our method can be easily combined with other methods. We can use the popular ControlNet to add depth image to control the image generation, stroke guidance, or pose. Notice that using our method, we can create style-aligned images across the different added controls. Our method can be combined with personalization methods. First, we fine-tune the denoising model so it can generate the striped cat. Then, given reference styles and our personalized diffusion model, we can create style-aligned images of our cat, or create style-aligned images across different personalized models where each model was trained on the subject on top. Thank you very much for listening.